Good day to everyone. So today our group will discuss the electromagnetic spectrum. The electromagnetic spectrum is the complete distribution of electromagnetic radiation based on frequency or wavelength. This electromagnetic spectrum is composed of electromagnetic waves. It encompasses all the electromagnetic radiation and is divided into numerous subranges such as visible light and ultraviolet radiation. Various portions of electromagnetic spectrum have different names due to the difference in the emission, transmission, and absorption of the corresponding waves, as well as their various practical applications. Because there are no precise accepted boundaries between these contiguous portions, the ranges tend to overlap.
Electromagnetic waves are produced by the motion of electrical charged particles. These waves are also called electromagnetic radiation because they radiate from the electrical charged particles. They travel through empty space as well as through air and other substances. Electromagnetic waves at low frequency are referred to as electromagnetic fields, and those at very high frequency are called electromagnetic radiation. Also, electromagnetic waves or EM waves are waves that are created as a result of vibration between an electric field and a magnetic field. In other words, EM waves are composed of oscillating magnetic and electric fields. In addition, electromagnetic waves are usually formed when an electric field comes in contact with a magnetic field. They are hence known as electromagnetic waves. They are also perpendicular to the direction of the EM waves. One of the most useful electromagnetic waves is visible light because it enables us to see. They are also responsible for transmitting energy in the form of microwaves, infrared radiation, visible lights, and ultraviolet light, X-rays, and gamma rays.
Radio waves. Radio waves have the longest wavelengths in the electromagnetic spectrum. It ranges from the length of a football to larger than our planet. The existence of radio wave is proved by Heinrich Hertz. In his experiment, he used a spark gap attached on an induction coil and a separate spark gap on a receiving antenna. The spark of the coil created a waves that get by the receiving antenna. Hertz's experiments showed signals possess the properties of electromagnetic waves. When you use radio, it receives the electromagnetic radio waves and converts it to mechanical vibrations. Microwave. Microwave is part of electromagnetic waves. The wavelengths of microwaves can be measured in centimeters. The waves that hit our food in a microwave oven are the longest microwaves. Another, microwaves transmit information from one to another place because the energy of the microwave can penetrate haze, light rain, snow, clouds, and smoke. Visible light. Visible light is the opposite of infrared. If infrared cannot be seen, this visible light can be seen by the human eye. All of electromagnetic radiation is light, but only a small portion of this radiation is we can see. Cone-shaped cells in our eyes as receivers tuned to the wavelengths in this narrow band of the spectrum. Other parts of the spectrum have wavelengths too large or too small and energetic for the biological limitations of our perception. As the full spectrum of visible light travels through a prism, the wavelengths separate into the colors of the rainbow because each color is a different wavelength. Violet has the shortest wavelength at around 380 nanometers, and red has the longest wavelength at around 700 nanometers. Infrared. The infrared is in between of microwaves and visible light. These infrared are not seen by the human eye. It is invisible to us, but we can feel and detect it by the heat. Infrared has wavelengths between 780 nanometers and 1 mm, which corresponds to a frequency range from 300 GHz to 400 THz. Infrared is used in electrical heaters, cooking food, short-range communications like remote controls, optical fibers, security systems, and thermal imaging cameras which detect people in the dark.
In the electromagnetic spectrum, ultraviolet or UV radiation is classified as having a wavelength from 10 nanometers to 400 nanometers. Also, ultraviolet UV lights has short wavelengths than visible lights. Although UV lights are visible to the human eye, some insects such as bumblebees can see them. This is similar to how dogs can hear the sounds of whistle just outside the hearing range of humans. Also, UV radiation is widely used in industrial processes and in medical and dental practices for a variety of purposes, such as killing bacteria, creating fluorescent effects, curing inks and resins, phototherapy, and sun tanning. There are also three primary health benefits of UV exposure are the production of vitamin D, improvement in mood, and increased energy. Moderate exposure to UV radiation is a good source of vitamin D. This vitamin aids in the regulation of calcium metabolism, insulin secretion, blood pressure, immunity, and cell propagation. X-ray are type of radiation called electromagnetic waves. X-ray imaging creates picture of your inside of your body. The image shows the parts of your body in different shades of black and white. The most familiar use of X-ray is checking for bone fracture, like broken bones, but X-ray are also used in other ways. For example, chest X-ray can spot pneumonia. Also, mammograms use X-ray to look for breast cancer. When you have an X-ray, you may wear a lead apron to protect certain parts of your body. In addition, X-ray are sometimes used to detect problems affecting soft tissues, such as internal organs. Problems that may be detected during an X-ray include bone fracture and breaks. X-ray can also use for non-medical man-made radiation. It's used in small amount in food irradiation, airport security scanner, and some consumers' product. Exposure to man-made radiation can happen in certain workplaces or in communities as a result of above-ground nuclear weapons testing and nuclear accidents. Gamma rays are usually found in all rocks and soil, even in our food and water. Artificially, sources of gamma radiation are produced in fusion in nuclear reactors, high-energy physics experiments like nuclear explosion and accidents. Also, they are produced by the hottest and most energetic object in the universe, such as neutron stars and pulsars, supernova explosion, and region around black holes. On Earth, gamma waves are generated by nuclear explosion, lightning, and the less dramatic activity of radioactive decay. Gamma rays also can be harmful because the extreme higher energy of gamma rays allow them to penetrate just above anything. They can even pass through bones and teeth. This makes gamma rays very dangerous.
Terahertz chips are new technology for seeing through matter, and they interact with various molecules in different ways, making them useful for characterizing certain substances. Photonic crystals, new materials that can manipulate and control light, are being worked on. The most promising are photonic crystals. They will have a significant influence on many of the issues explored in this foresight research. Optical tweezers. It is a type of optical tweezers that are used to laser that are already used to grip and manipulate molecules in the same way as tweezers are. The future difficulty will be to manipulate several particles at the same time. Image processing techniques. In astronomy, image processing and digital signal processing are used for everything from identifying and characterization of celestial bodies and determining their distance from Earth and assessing the physical properties of the object in the image using signal data.